Hello students, today we will cover some very important topics in geology, the continental drift hypothesis, the modern plate tectonics theory, and the different types of rocks along with the rock cycle. These concepts explain how our Earth's surface has changed over millions of years, why earthquakes and volcanoes occur, and how rocks are constantly recycled. Let's start with the continental drift hypothesis, proposed by Alfred Wegener in 1915. According to him, about 250 million years ago, all the continents were joined together into a single massive supercontinent called Pangaea, surrounded by a huge ocean known as Panthalassa. Later, this landmass split into two parts, Laurasia in the north, Gondwanaland in the south. From there, the continents slowly drifted to their present positions. What was Wegener's evidence? He used several clues, matching coastlines. For example, the east coast of South America and the west coast of Africa fit together like puzzle pieces. Fossil evidence, identical fossils of plants and animals like Mesosaurus, were found on different continents separated by oceans. Similar rock strata, rocks and mountain belts on different continents matched in age and structure. Glacial deposits, marks of ancient glaciers, were found in places like India and Africa, showing they were once located closer to the South Pole. Although Wegener's idea was revolutionary, at that time he could not explain how continents drifted, so many scientists rejected it. Decades later, Wegener's idea was refined into the modern plate tectonics theory. This theory states that the Earth's lithosphere, the outer rigid shell, is broken into about 20 plates, 7 major and many minor. These plates float on the softer asthenosphere below and move slowly, just a few centimeters every year. This theory successfully explains the distribution of earthquakes, volcanoes, and mountains. Types of plate boundaries, divergent boundaries, plates move apart and new crust is formed. Example, the mid-Atlantic ridge, where the Atlantic Ocean is slowly widening. Convergent boundaries, plates collide. If both are continental plates, mountains like the Himalayas are formed. If oceanic and continental plates meet, trenches and volcanic chains like the Andes form. Transform boundaries, plates slide past each other horizontally. Example, the San Andreas Fault in California, famous for earthquakes. So, plate tectonics gave us the mechanism missing in Wegener's hypothesis, the driving force of mantle convection currents that move the plates. Rocks, the building blocks of Earth. Now let's move to the rocks, which form the Earth's crust. A rock is simply a natural solid aggregate of minerals. There are three main types of rocks, formed by the cooling and solidification of magma. Extrusive igneous rocks like basalt and pumice formed on the Earth's surface. They cool quickly, so they are fine-grained. Intrusive igneous rocks like granite and gabbro form deep inside the crust. They cool slowly, so they are coarse-grained. Characteristics: hard, crystalline, called primary rocks, and contain no fossils. Formed by deposition and compaction of sediments over time. Types: mechanically formed, example sandstone, shale. Chemically formed, example rock salt, gypsum. Organically formed, example limestone from shells, coal from plants. Characteristics: layered or stratified, porous, and often contain fossils, making them very important for studying Earth's history. Metamorphic rocks formed when pre-existing rocks are changed by heat, pressure, or chemical processes. Examples: granite gneiss, limestone marble, coal graphite, shale slate. Characteristics: very hard, crystalline, and often foliated, arranged in layers. Finally, let us understand the rock cycle, which shows that rocks are not permanent but keep changing from one form to another. Igneous rocks undergo weathering and erosion, become sediments, compact to form sedimentary rocks. Sedimentary rocks, under heat and pressure, change into metamorphic rocks. Metamorphic rocks, when melted, form magma, which cools to produce igneous rocks again. This cycle is continuous and explains how Earth constantly recycles its crustal material. So students, today we learned the continental drift hypothesis by Alfred Wegener and the evidence behind it. The plate tectonics theory, which explains the movement of Earth's plates and the formation of landforms. The three types of rocks, igneous, sedimentary, and metamorphic, along with the continuous rock cycle. These topics together explain how the Earth is a dynamic planet, always changing, reshaping, and recycling itself. That's all for today's lesson. Thank you for listening. Jai Hind.